Greetings to all of you who are joining today's webinar. My name is John DeVoe and I will be your host. Today's topic is transforming data security for modern, cloud-first, agile enterprises. Our presenters today are Mark Bauer from Conforte Inc. and Puneet Singh from Encryption Consulting. Conforte and Encryption Consulting have partnered together to offer expertise and support for organizations interested in data security with a deep focus on data encryption and tokenization. Encryption Consulting offers services around PKI requirements, encryption strategy consulting, cryptography-focused products, and more. Conforte offers a data security and privacy platform which is built to modern infrastructure as code models for ease of deployment, automation, and scale, and total control and governance of sensitive data. This webinar will walk through proven governance strategies to consider for a data security transformation journey through real-world successes, including a large US financial services leader faced with complex operational and cloud-based personal data handling needs. Both Mark and Puneet will each start with a short introduction and then jump right into the topic. Okay, Mark, let's start with you.
Thanks, JD. So my name is Mark. I head up product strategy for Conforte. So just a brief introduction to Conforte. We have around 500 customers globally, and in fact are often behind the scenes of many of the world's leaders in protecting information that flies around the world today, and including probably your data as well. We offer the capabilities to help organizations discover sensitive data risks and then protect that information as it flows across modern IT platforms. And I'll detail a little bit more of that today, but I'm going to hand over to Puneet to introduce Encryption Consulting.
Thank you, Mark. As the name suggests, Encryption Consulting, we normally focus on all the aspects of the encryption, and both symmetric as well as asymmetric. And our major winner in the market has been that we have been developing encryption strategy as well as doing assessment for the Fortune 500 companies. And that being said, I'll hand over back to you, Mark. Mark, do you want to go ahead?
Great, thanks, Puneet. So the way that we see the world at Conforte and the reasons why many organizations come to us really spans three critical problem areas with regards to data security and risk. The first relates to modern data privacy and compliance. Today, organizations are faced with new challenges with regards to privacy mandates that have echoed around the world, starting with GDPR in Europe, but now very common in places like California, Virginia in the US, Brazil, South Africa, and so forth. The challenge now is that organizations aren't just faced with the risk of protecting information that they collect. Information is essentially donated to them. And this changes the way they have to think about and manage data security. So effectively, that's both a technical change and a culture change as well. At the same time, we have organizations that are transforming their IT architectures to modern cloud-native versions of what was before. We've gone well past cloud migrations, now into refactoring applications for modern cloud infrastructure. This is to take advantage of the agility that we can achieve with these new platforms. But what comes with that is new risks. We're able to do things far more quickly. We're able to adapt to change more rapidly. But the amount of data that we can now collect and process, particularly in machine intelligence platforms, presents new threats from a privacy risk and exposure perspective. And of course, the traditional controls often don't work as well in these types of agile environments. Techniques like DLP or identity access management or data at rest protection can become problematic when the ecosystem changes dramatically and where data flows almost anywhere. And of course, the shift to machine learning platforms, lured by their capabilities, is highly desirable to be able to have faster outcomes, particularly in post-pandemic IT platforms. And of course, the risk of exposure is magnified. In these types of environments, the agility levels go through the roof. Scientists need to be able to access vast amounts of data in order to uncover the unknown in data sets. And that means changing tools almost on the minute. If we take a quick look at a modern data ecosystem, organizations have been transitioning from the classic data warehouse and operational platforms to a much more continuous, integrated data operation and data science platform built around what we now refer to as data engineering. Essentially, the opportunity to acquire more and more data from sensors, devices, applications, SaaS platforms, business partners, as well as our classic infrastructure, presents a new way to be able to take the data from these environments and move it into these science platforms for outcomes. But of course, there's a need for data security and governance across all of this type of ecosystem. Certainly, the amount of data that could be exposed could be very dramatic from a breach risk perspective. If we think about those older controls, though, like DLP, which often becomes a rear vision mirror for data leaving an organization, or the types of controls that we need with respect to privacy, there's a big difference between what we have and used in the past and what we need today to govern that data that has essentially been donated to us. If we take a deeper look at this, the classic infrastructure we have on the left, monolithic applications, was often protected in a piecemeal approach. We had perhaps data at rest protection, protecting data that was in storage, or database encryption or table encryption, protecting again data that was in storage. And as data moves through the organization, moves up to people who themselves are also vulnerable to attack, we end up with a piecemeal approach to data security. And what this means is that we have gaps that can be either exploited, that can result in exposures from misconfigurations as data leaves data at rest, moves through an organization, and essentially becomes exposed to threats. Now, of course, when you move to a modern ecosystem where you're using microservices and serverless compute, workloads can come and go on the fly. We might be using infrastructure or containers that contain data processing that we have less observability about and less control. So the ability to close gaps across all of these types of architectures, be it classic infrastructure as on the left or in this modern infrastructure on the right, is paramount to a data transformation process and a successful outcome in being able to exploit the value that modern data architectures can provide. So let's take a quick look at how we can do this. Let's say we have some typical sensitive data here on the left, names, socials, date of birth, and so on. If there was the capacity to dynamically and transparently protect that information in a way that essentially retains the value of the information that we are collecting, and yet when it's stored and used in a database or migrated to a data lake, it essentially is no longer the live data, then if we can balance the ability to use this data with the control over access to the live data only when necessary, we can achieve what's called a zero trust data security model. That is, by default, data should remain and stay protected wherever it goes, and on access, be very granularly controlled. And through this technique, being able to do this in a transparent way gives us a lot of power to protect data from those operational platforms all the way through to the machine intelligence, including using it in analytics. Now, of course, if you have an attack and an insider gets access to the data that's unauthorized, they're essentially getting something that's useless. We've rendered that data effectively inoperable as far as the attacker is concerned. In things like GDPR, this is often called pseudonymization technology, for example. Now, this technique is something that we have helped pioneer with industry standards. In fact, we worked very closely with the ANSI X9 group and leading vendors and industry bodies from the financial services community to bring this technology to bear in a way that can be incorporated into an accepted financial standard. If you want details of that, don't hesitate to get in touch. So the technology is one thing, but implementing this type of technology at scale can be problematic, particularly when you have an ecosystem that contains multiple different types of platforms that span different environments, be it different types of clouds, your own private cloud, perhaps built on Kubernetes, an analytic platform that's running in AWS or GCP, for instance, or a development environment that might be in a completely different cloud. So we need a way to implement quickly. So let's look at how somebody did that. That's a large organization that had two serious problems. One was a very pending data privacy deadline. in fact, a very specific regulation under NACHA rules to protect banking-related information within its platforms. It also had very complex infrastructure, so a blend of hypermodern machine intelligence platforms in the cloud, but also classic infrastructure across many, many applications and many databases in the classic data center environment. So, like many, and you saw this diagram before, this organization was trending towards this type of architecture. The modernization and the transformation of its core IT processing platforms for things like financial services and claims processing, and the utilization of very contemporary data science to get the most use out of the data at hand. But of course, when you look under the covers, there was a number of compliance challenges and risk exposures. Simple things like having an offshore development team or an offshore management team managing operations can create problems from a compliance perspective, for instance. So even though this organization actually had a number of critical technologies already in place, the challenge was they weren't suitable to a modern cloud ecosystem and a transformation project. And in fact, were actually impeding it. In fact, existing data tokenization was in place, but largely focused around a PCI use case and not really compatible with protecting personal data at scale and in an agile way. They had existing data masking, but it was really built for app dev and test environments, not machine learning, where you need to have very vast models being created and vast data sets in order to tune them. So there was a need to be able to scale to that kind of level. Existing data at rest was always an option, but really not suitable because once again, it only protects data in a state that is at rest as described. And data moves around, particularly when it's going into science platforms and when it's potentially being utilized in all sorts of different analytics processes. And of course, to try and figure out what the risks are, when you're an organization of this size with this many applications, that can become a really big problem. And they had a first generation data discovery solution that literally was only able to find what you told it to look for and where to look, which defeats the challenge. We need to uncover the unknowns and where the risks truly are across the enterprise. So the project was split into two. The first part was using the technology to intelligently figure out what sensitive data was stored, processed, and used across their business, whose data it was, which customers it actually belonged to, why it was stored, and where it flowed. That allows an organization to look for the different types of controls that may or may not exist, and then augment them with a data security approach. So in this case, the operational platforms were secured first in order to achieve the compliance deadline, but the same data could also be then utilized end to end without gaps in security in the analytic environment. But if we look closely, there's a very specific problem this organization had challenges solving. And it might seem like a very simple problem at first, but it's actually quite complex to solve and to do it well in this end-to-end way. So here we had applications in their claims processing environment. And like with many insurers, you have customers and customer service connecting together for things like quotes, claims, and engagement for customer service. And all too common, the agents would collect personal data as a matter of process. Even though they were told never to collect this type of data and put it in these kinds of free-form text fields, which went into the database just as notes, the problem was it was so convenient and easy and efficient that it was done every time. So what we were able to do to achieve compliance to the pending regulation and the privacy rules was automatically protect this information in place using modern tokenization without changing the rest of the data. So here we can preserve the utility in the information so that as that data then moves to the science platforms, it can be analyzed without exposing the personal data. We've essentially de-risked this data. We can then run science, and if we need to, act on the outcome of looking at the sentiment in the data, as well as the what was personal data. We can now complete the loop and re-identify a customer that might need some extra care. So this is just a simple example. And when you scale this out across hundreds of applications, the capacity to do this very rapidly is critical to success. So this was some of the challenges that they had and perhaps the outcomes that were from this transparent approach. So a traditional way of trying to solve these problems is to use APIs. This requires you to open up applications, possibly use multiple resources to do it, rebuild, recompile, and then move the applications to production. And given the kind of agility organizations have, this is kind of dead work, essentially. We were able to solve this problem really fast with this more transparent integration. The implementation was also able to be done in some commercial off-the-shelf applications, which often crop up in core processing. In this case, a significant master data management ecosystem with heavily groomed personal data present everywhere at scale. So both a risk, a compliance challenge, and something that could actually be solved relatively quickly. And because the data was actually protected in a way that preserves the meaning and the utility, the data could be moved to the science platforms, analytics could be performed, and when there was the need to actually access the real data, we were able to implement a very simple process to do that, so that could be handled independent of the machine learning platforms. So again, it's end-to-end closure of data security. So it's not just in financial services that this technology applies. It can apply to any organization that's faced with privacy issues, regulated sensitive data across operational platforms through to machine intelligence and other types of processing environments, possibly sharing it with partners. The 4 use cases tend to be protecting data in production, which is a pretty important one, reducing the risk of exposure in analytics, so non-production data, possibly in test and dev as well, and to enable the wholesale adoption of cloud and cloud-native technologies without worrying about data exposures as applications change, as they're deployed and used. And last of all, and not forgetting that organizations with mission-critical or legacy platforms that need to be modernized to new compliance requirements, or maybe move to the cloud with a lift and shift approach, can also be retrofitted with this type of technology. It's delivered from a cloud-native platform that works well with the CI/CD, so it works really nicely with a DevOps ecosystem. It's essentially fully automated on the back end, so lights out, and can be then consumed transparently by the business with a more plug-in architecture than code-in. And this can be underpinned with a very powerful data discovery process. So if you don't know where your data is, you've got a way to start with some automated approaches, perhaps along with the governance approaches and consulting from our partner here. So last of all, before we wrap, just very briefly to recap, we can help organizations with structured, sensitive data scenarios, applications, databases, data lakes. And we'd certainly love to engage with you. And you can get in touch with us through these contacts here as well. So you can either get in touch with myself or Puneet. Thanks for your time, and we look forward to engaging you.